Okay, so let's discuss next how do we evaluate significance-based research claims. And we're going to do this in two parts. So we're first going to talk about null findings. So a null finding is something where you have a p-value of over 0.05 normally. But basically, it's a research paper that says that something was not found. Um, they sometimes say that something doesn't exist, or we found evidence that this thing doesn't work, but that's normally bogus. But we'll discuss. And in the next section, we'll talk about these questions and rules of thumb for um, um, statistically significant findings. So let's go. First of all, if they say that there was no effect, or we found no difference between these groups, and they say that there is a high p-value to prove this. So first thing you should ask if you see something like this, it's like how hard did they actually look? Because the thing is that the harder you look, the more likely you are to find something. And one example of this is that like the more data you collect, the more likely you're going to see an effect. So the intuition is that if there is an effect that's not obvious, it can be hard to detect. And the probability of detecting some effect in the long term, getting a statistically significant result if the effect is real. So this is what we call statistical power. It's a very weird term, but what do you do? So the thing is that if you collect enough people and you look hard enough, you'll always find something. And it's sometimes easy to say that, hey, something doesn't exist if you are not really even looking. So you need to know whether how hard did people try to look for an effect. The thing is that it's this probability of detecting the effect is usually set at 80%. And that's just an arbitrary convention, just completely out of the blue. And like the statistical significance threshold of 0.05, it was also said that you should think about this very carefully. But people don't. They set it at 80% just because of reasons. So this means that if what you're studying is a real phenomenon, in the long term, every fifth study or the analysis you would do, you would actually end up thinking that this phenomenon is not real, and you don't have an effect of these things. And the statistical power is higher, so the probability to detect an effect is higher when the sample is bigger, or the variables have less variance, so that people are very similar in terms of the things that you study, for example. And if you go back to the spreadsheet that I showed, maybe it was in video 4. Where we did the fake correlation based on the two sets of random numbers. So you saw that when we put the values up to 1000, you always got the statistically significant result. So the point is, one of the points is also that an experiment designed with low power is not worth performing. And this is what the person who was part of developing these statistical tools was quoted saying. And one thing you can always ask is, well, how are we doing on this? Because this was in '77. So how are we doing on this with things that actually matter? And many psychology studies actually don't really matter. uh, uh, so let's talk about masks as an example. So in 21, there was this study that looked into the statistical power of mask studies. And they did a lot of very smart things in that analysis. But one interesting thing that they found out was that these studies were so underpowered that even if the masks were 100% effective, the studies would have still been unlikely to find a statistically significant effect. So we return to the point, what was the point? Because in many of these studies, the control group wears the mask as much as the intervention group, and there are many problems in trying to make people wear masks, especially if they don't consider there to be a lot of threat and so forth. But the thing is that physics actually tells us that this that masks do work, especially the high quality masks. So what we in Europe we call them FFP2 or FFP3 type of masks, or respirators. So we have the physics, and it's not an epidemiology study cannot disprove physics any more than the psychology study can disprove physics about extrasensory perception or precognition that we spoke about in the beginning of week 1 this course. So there was also an interesting turn in events when there was a Cochrane review. So Cochrane collaboration is one of the most famous evidence gathering groups that do these different meta-analysis and so forth. And their meta-analysis was so biased that there had actually had to be a person who was the editor-in-chief had to intervene and apologize for how this Cochrane review that showed that masks don't work, that they had the people who had been making these claims about the meta-analysis had not represented the evidence correctly. And this was all over the news when they found out that when they published this review, and everyone was like, oh, hey, I always knew that masks don't work, but I haven't really seen anything about this apology in the news. So let's have a break here.